Good morning, students. Welcome to Unacademy, welcome to Kreatryx, and welcome to Impulse Batch. Before going to start the topic, let me introduce myself. I'm KV Swami. I did my MTech in Systems and Signal Processing from JNT College of Engineering, Hyderabad, and passed out in the year 2007. And since 2009, I was into this GATE coaching field, teaching the subject Signals and Systems and Communication throughout the country. I have total of 12 plus years of teaching experience, and now I'm associated with Unacademy. And if you want to purchase any course on Unacademy, you can use my code KVS Live, with which you'll be getting flat 10% discount. Any course on Unacademy you can purchase using the code KVS Live. First of all, we'll observe what are the various courses for GATE we are having in Unacademy. Basically, we are having two types of subscriptions, namely the Plus subscription and the Iconic subscription. In the Plus subscription, the student is exposed to live classes, crash courses, weekly tests are conducted, doubt solving sessions are there, and batches are conducted in both English and Hindi. If a student is not comfortable with English, he can take the batch in Hindi, and if a student is not comfortable with Hindi, he can take the batch in English from his choice of educator. Apart from this, we have one more type of subscription known as Iconic subscription, in which a mentor is allocated to the student. So here a personal coach will be there, study planner is given to the students, study booster sessions are there, personalized test analysis is there, detailed dedicated doubt clearing instructors are there, and preparatory study material is also given. Now, if you observe the fee structure in the Plus subscription and Iconic subscription, in the Plus subscription, GATE or ESE preparation for 12 months, that is 1 year, it costs around 27,225 rupees only using the code KVS Live. Plus subscription, GATE or ESE preparation for 18 months, that is 1.5 year course, it costs around 34,650 rupees only using the code KVS Live. In the Plus subscription, GATE or ESE preparation for 24 months, that is 2-year program, which is ideal for second year students, it costs around 39,600 rupees only using the code KVS Live. Coming to the next subscription, that is Iconic subscription. So in Iconic subscription, GATE or ESE preparation for 12 months, that is 1 year, it costs around 45,225 rupees only using the code KVS Live. GATE or ESE preparation in Iconic subscription for 24 months, 2-year program, it costs around 66,600 using the code KVS Live. So whatever may be your choice, either Plus subscription or Iconic subscription, use the code KVS Live. KVS Live. And one more good news for all the students is that this week, that is on 4th of April, Unacademy is going to conduct an exam known as Unacademy Combat. So which is a 60 minutes online exam, and the branches eligible are mechanical engineering, civil engineering students, electrical engineering students, electronics and communication, and computer science and information technology. The advantage of this Unacademy Combat is that if you're lying in the top 3, if your rank is in the top 3, see, you'll be getting a 100% scholarship on Plus subscription, means you need not pay anything for Plus subscription, and 100 winners from each branch will be given additional discounts. So save the date, this is going to happen on 4th April. 4th April, inform your friends also, 11 AM. Duration is 60 minutes. Okay, 1 hour. And in order to write this Unacademy Combat, you can use my code KVS Live. KVS Live. Fine. Now let's get back to our topic. So before that, good morning all of you. Those who are coming new, subscribe the channel and share the session, and give your attendance by pressing the like button. Give your attendance, all of you. Give your attendance, all of you. Good morning, Amresh, Jaitirtha, Adarsh, Harish, Vamsi. Fine. Yesterday, what we were discussing, yesterday we entered into a new topic known as systems. Systems. If you do a small recap on the yesterday's topic, first of all, we define system. How we are going to define system? A system is an entity which takes the input as a signal, performs some necessary operations on the input signal, and produces the corresponding output. This is a definition of the system. And what I said, a system is always specified by a input output relationship. System is always specified by a input output relationship. For example, y of t is equal to d by dt of x of t. Means what is the system doing? The system is simply differentiating the input signal, right? Y of t is equal to integral minus infinite to t x of tau d tau. Now what is the system doing? The system is simply integrating the input signal, or in general will denote it as y of t is equal to some transformation is done on the input signal x of t. After that, we have seen the types of systems. How many types of systems we have? Two types of systems: continuous time systems and discrete time systems. Discrete time system. Continuous time system means what? Both input and output are continuous time quantities. For a continuous time system, both input and output are continuous time quantities. Whereas for a discrete time systems, both input and output are discrete time quantities. Discrete time quantities. So for continuous time system, we'll specify like this: x of t applied to the system produces y of t. For discrete time systems, we'll specify like this: x of n applied to the system produces y of n. Right? After that, we were looking at the properties of the systems. What is the first property? Linearity. Linearity. So for checking linearity, what is the procedure we are going to follow? Linearity means a system is said to be linear if it satisfies superposition principle. Means additivity must be followed, homogeneity must be followed. So how you are going to check? If you are given the input output relationship, in the first step we'll apply x1t so that we get y1t. In the second step we'll apply x2t so that we'll get y2t. In the third step, we'll apply linear combination of inputs ax1t plus bx2t. As a result, if you are going to get ay1t plus by2t as your output, your system is linear, otherwise non-linear. See here in the single expression, additivity is there. Additivity is there and homogeneity is also there. Additivity is there, homogeneity is also there. Additivity means what? x1 of t plus x2 of t applied to a linear system must produce y1 of t plus y2 of t. Homogeneity means c times x of t applied to a linear system must produce c times y of t. But instead of checking separately, you can test with the single expression. So if you are applying ax1 of t plus bx2 of t, and if you are going to get a by 1 of t plus b by 2 of t, your system is said to be linear, otherwise non-linear, right? And one more point also I told you that for a linear system, zero input, zero output property must be satisfied. One consequence of this homogeneity property is that if input is zero, output is zero. So zero input, zero output property must be satisfied, and we'll say that this condition is necessary but not sufficient to judge. Necessary but not sufficient to judge for linearity, because many non-linear systems also satisfy this zero input, zero output property. And I told you that for a linear system, the input-output relationship, if you are trying to plot, it must be a straight line passing through the origin. It must be like this. And one more point I want to say that in homogeneity, this C here what we are going to have, this can be a real value, or this can be imaginary, or this can be complex also. The C, which is a constant, can be real or imaginary or complex also. And we have seen some examples also yesterday. Y of t is equal to 2 times x of t, 2 times x of t plus 3, y of t is equal to x square of t, x of t square, sine of x of t, x of sine t, x of t multiplied with cos 3t. Okay, so various examples we have seen, right? As a continuation to the examples, observe here. Suppose if I ask you y of t is equal to mod of x of t, linear or non-linear? Y of t is equal to mod of x of t, linear or non-linear? Fatafat, you tell me the answer, all of you. Jayatita, we are going to discuss that your doubt in detail, don't worry. I understood doubt. Mod of x of t is linear or non-linear? See, try to plot the input-output relationship. We know if this is x of t, this is y of t, mod of x of t input-output relationship will be like this, no? Right? So linear or non-linear? Non-linear. Non-linear. Because due to this modulus, what will happen? Homogeneity will be failed. If I am go C into homogeneity means what? C into x of t must produce C into y of t. Suppose if C is negative value due to the presence of this modulus, it will become positive value. So it is non-linear. From the input-output relationship you can say, and here what will fail? Homogeneity will fail. Homogeneity will be failed. Y of t is equal to modulus of x of t is non-linear. Suppose if I ask you this one, y of t is equal to signum of x of t, linear or non-linear? What you tell me the answer? Signum of x of t, linear or non-linear? See, first of all, let's draw the input-output relationship better. Look here. Signum t means, what do you know? Signum t means, how we are going to draw? It is 1 for t greater than 0, and 0 at t is equal to 0, and minus 1 for t less than 0. So that the shape of signum t is given like this, which is an odd signal. In the same way, define signum of x of t. In the place of t we have x of t. So what will happen? It is 1 if x of t greater than 0, 0 if x of t is equal to 0, and it is minus 1 if x of t less than 0. So what could be the shape? This is x of t, this is y of t. So x of t greater than 0, signum of x of t value is 1. X of t less than 0, signum of x of t value is minus 1. Now linear or non-linear, but we have seen that linearity means these kind of characteristics we must have. So this is non-linear. Non-linear. Signum of x of t is non-linear. Suppose, hope this is completed. If I ask you this one, y of t is equal to x star of t, x star of t, x star of t, x conjugate of t. A star denotes conjugate. Linear or non-linear? X star of t. Come on, my dear students. What happened to Manu? Manu is absent today. Do it. Nanda Kumar, non-linear. Okay. Can I write this as y of t is equal to x of t conjugate like this? Yes. So follow the procedure. In the first step, y1 of t. In the first step, apply x1 of t. In the second step, apply x2 of t. Apply x2 of t. In the third step, what is their input? In the third step, what is their input? In the place of x of t, substitute ax1 of t plus bx2 of t. Ax1 of t plus bx2 of t. Or how you can write this one? A star into x1 star of t plus b star into x2 star of t. This is y3 of t. What is ay1t plus by2t? Ay1t plus by2t is what? Ay1t means a x1 star of t plus b x2 star of t, right? A by 1t plus b by 2t. Now we have to see whether our y3 of t is equal to a by 1t plus b by 2t or not. Okay, here if you observe, if a is a real quantity, if a is a real number, so no problem. Here what we discussed, here I said a can be real or imaginary, or it can be complex also. Now if a is real, if a and b are real, no problem. But what happens if a and b are complex? Complex means what will happen? Here a came, here a conjugate came, so they are different, no? So linear or non-linear? Non-linear. 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 If a and b are real, no problem. But if a and b are a and b can be any values, they can be complex also, so it is non-linear. Non-linear. Remember, whenever conjugate appears, non-linear. Wherever conjugate appears, you can simply put it as non-linear. For example, y of t is equal to, I ask you, real part of x of t. Something like, if I ask you real part of x of t. Real part means how you are going to write? X of t plus x star of t by 2, no? Right? So conjugate came means non-linear. Non-linear. You can simply write. So wherever conjugate appears, non-linear. In the same way, imaginary part of x of t also non-linear. Right? Sometimes completed. Yes. Observe here. Sometimes what happens, the input output relationship of a system is specified by a differential equation. Is specified by a differential equation. Look here. So how to check linearity if differential equation is given? Differential equation is given. How to check linearity if differential equation is given? First point, no term in the differential equation is a constant. See, constant should not appear in the differential equation. No term in the differential equation is a constant. If constant is appearing in the differential equation, means simply you can put it as non-linear. Non-linear. Second one, the coefficients of the terms can be functions of independent variable but they cannot be the functions of dependent variable. Take down these two statements. If you can follow these two statements, given any differential equation, you can simply say whether it is linear or non-linear. Take down, I'll give you examples. Very, very important. First point is what? No term in the differential equation is a constant. If constant appears in the differential equation, if a constant term appears in the differential equation, simply non-linear. Next, the coefficients of the terms can be functions of the independent variable, but they cannot be the functions of the dependent variable. Dependent variable, right? So let's see with examples. First one, dy of t by dt plus 4 times y of t is equal to x of t. Look here, dy of t by dt plus 4 times y of t is equal to x of t. Listen carefully, afterwards you'll get confusion. Listen carefully, all of you. Dy of t by dt plus 4y of t is equal to x of t. This is a differential equation. So differential equation means, what is the first check? No term in the differential equation is a constant. Is there any constant kind of thing? No. And the coefficients of the term can be functions of independent variable, but they cannot be the functions of the dependent variable. Here if you observe, no function, no coefficient is dependent on the independent variable or dependent variable. So this is linear or non-linear? Linear we will classify. Linear. Linear. Okay. Suppose the same differential equation if I give you like this, dy of t by dt plus 4y of t plus 3 is equal to x of t. Come on, tell me, linear or non-linear? Second one. Second one, linear or non-linear? Second one, dy of t by dt plus 4y of t plus 3 is equal to x of t. See here, constant is appearing. Constant is appearing. It should not appear. So non-linear. non-linear, right? Suppose if I ask you this one, dy of t by dt plus 4ty of t plus 6 is equal to x of t. Linear or non-linear? Linear or non-linear? Tell me. Here, first one, if you observe, constant is appearing, means non-linear. But here, if you observe, the coefficient is dependent on the independent variable. This is allowed, but this is not allowed. So overall, not allowed. Non-linear. Non-linear. Suppose if I ask you this one, dy of t by dt plus 4ty of t is equal to x of t. Linear or non-linear? What you must tell me. Dy of t by dt plus 4ty of t is equal to x of t. Here, if you observe the coefficient is what here? T. So the coefficient can be a function of independent variable. It is allowed. Linear. Linear. Suppose if I ask you this one, dy of t by dt plus 4t square into y of t is equal to x of t. Linear or non-linear? Linear or non-linear? Tell me. T is allowed, t square is also allowed. It is linear. Suppose if I ask you like this, dy of t by dt plus 4 y of 2t into y of t is equal to x of t. Linear or non-linear? Tell me. Linear or non-linear? Here coefficient, if you observe, one coefficient is dependent on, is a function of what? Dependent variable. It should not be. Non-linear. Non-linear. Okay. Next one. Clear? Number 7. Dy of t by dt minus 2y of t is equal to e power x of t into x of t. Linear or non-linear? Tell me. Linear or non-linear? Here if you observe, x of t coefficient is e power x of t, means it is a function of the dependent variable. So it is non-linear. Non-linear, right? So in this way, if you are given a differential equation, I am pretty sure that you can classify it as linear or non-linear. So what must be observed? Constant should not appear. Constant should not appear in the differential equation. That the coefficients what we are having, they must be function of the independent variable, but they should not be the functions of dependent variables. Dependent variables, right? One more I'll ask, tell me, simple one only. D square y of t by dt square minus 4t into dy of t by dt is equal to x of t. Linear or non-linear? Linear or non-linear? It is linear, exactly. Linear. Because constant is not there and the coefficients are functions of the independent variable. Suppose if I put some plus 3 or plus 5, this becomes non-linear. If I put some plus 5 or something, it becomes non-linear. Fine. So let's solve one more problem. This is about the differential equations. Okay. Look here. Next question. I'll take in the next paper. Better. Fine. A continuous time system. A continuous time system. Yes. Is having the input output relationship as, look here, this is the input output relationship for the system. Is saying that if you apply an input e power j to t, the output y of t is e power j3t. And he's saying that if you apply the input x of t is equal to e power minus j2t, the output of the system y of t is e power minus j3t, he's saying. Find the output y of t if x of t is equal to cos 2t and x of t is equal to cos of 2t minus 1. Sorry, this is linear system. I forgot it. Here a continuous time linear system. A continuous time linear system S is having the following input output relationship. Jaitirtha, in the seventh one, they are functions of the dependent variable, right, sir? Seventh one. Functions of dependent variable. So that's why we said non-linear, Jaitirtha. They can be functions of independent variable, but they should not be the functions of dependent variable. Jaitirtha, please observe. This is an important question. Very simple question. For the system, yes, if you are going to give e power j2t, you are going to get e power j3t. E power minus j2t you are going to get e power minus j3t. Now is asking what happens if I give x of t is equal to cos 2t and cos 2t minus 1. Any answers? Try to solve and type your answers fatafat. Observe here. Exactly, you are right, Gajendra Singh. Additivity principle you have to apply. See, first one is what? Cos 2t. X of t is equal to cos 2t. How can I write? Can I write it as e power j2t plus e power minus j2t by 2? Implies this is nothing but 1 by 2 e power j2t plus 1 by 2 e power minus j2t. Our system is what? Linear system is set. Linear system is c into x of t. If you apply, what will get? C into y of t you will get. So here y of t will be, look here, c value is 1 by 2. So 1 by 2. This is c into x of t, c into y of t. What is the output due to this e power j2t? E power j3t plus 1 by 2 again. What is the output due to e power minus j2t? E power minus j3t. This is nothing but e power j3t plus e power minus j3t by 2, which is nothing but cos 3t. Output of the first problem is cos 3t. Cos 3t. Cos 2t if you apply, cos 3t will get. In the same way, you can go with cos 2t minus 1 also. Xt is equal to cos of 2t minus 1. How can you write this one? E power j times 2t minus 1 plus e power minus j times 2t minus 1 divided by 2. Or you can simplify this as e power j 2t e power minus j by 2 plus e power minus j 2t into e power j by 2. Now e power minus j by 2 is anyway constant, no? So use homogeneities. E power minus j by 2. What is the output due to this e power j 2t? E power j 3t plus e power j by 2 is constant. What is the output due to e power minus j 2t? E power minus j 3t. Or again I can simplify this as 1 by 2 e power j, if you take common 3t minus 1 plus 1 by 2 e power minus j, if you take common 3t minus 1, or this is nothing but cos of 3t minus 1, right? So the first answer is cos 3t and the second answer is cos 3t minus 1. Take down. Jethida, please verify. Look at the statement. Right? Yes, Jethida. Simple analysis, simple analysis. I know that you can analyze. That's why I didn't explain that one. So this is regarding linearity, students. Okay. And I hope that given any problem under linearity, you can solve. Let's look at the next property of systems, that is nothing but time invariance. Time invariance. Linearity is completed. Time invariance. After time invariance is completed, we'll combine linearity and time invariance and we'll form LTI system, and how the differential equation for a LTI system looks like and all that analysis we'll do. But before that, we must know what is this time invariance. Observe here. I'm taking a continuous time system. Look here. I'm taking a continuous time system with input x of t. Some transformation is done on the signal x of t to produce the output y of t. So that I'll write x of t applied to the system is producing y of t. X of t applied to the system is producing y of t. After some time, what I'll do is I'll try to delay the input by small amount. Again apply to the system. I'll delay the input by small amount and again apply to the same system. As a result, if output also gets delayed by the same amount, then I can say that this time shift operation is not having any effect on the input output relationship of the system, or the system is said to be time invariant, otherwise time variant. So the definition is, okay, a system is said to be time invariant. A system is said to be time invariant if time shift operation is not having any effect, on the input output relationship of the system. Is not having any effect on the input output relationship of the system. Otherwise, the system is said to be time variant. Otherwise, the system is said to be time variant. Or in word, we can say that time invariant system is input delay must be equal to output delay. Input delay must be equal to output delay. Yes, Gajendra, you can verify, no problem. I said no, time shift is not having any effect. It may be delay, it may be advance. It can be anything, no issues. Right? System is said to be time invariant if time shift operation is not having any effect on the input output relationship of the system. Right? This is the definition. Now, we have one procedure for checking the time invariance. Procedure. You follow the procedure, you can get the answer for any problem. Procedure. First step. Delay the input by T naught and denote the corresponding output as y of t comma t naught. First of all, delay the input by t naught. Delay the input signal by t naught and apply to the system. Whatever the output you are going to get, you are going to call it by y of t minus t naught. Second, delay the output by t naught and denote the corresponding value as y of t minus t naught. Y of t minus t naught. Third point, you can write delay or you can write simply shift also, no issues. It can be delay or it can be advance. If y of t comma t naught is equal to y of t minus t naught, the system is said to be time invariant. Time invariant. Otherwise, time variant. For discrete, suppose for a discrete time system, for time invariant, the condition is y of n comma n naught, y of n minus n naught. This must be satisfied for time invariance. Okay. Completed? Now check the following systems for time invariance. Check the following systems for time invariance. First problem is the same problem what we took in linearity. 2 times x of t. 2 times x of t. Now we have to see whether this is time invariant or time variant. First of all, here what is your input and what is your output? Here input corresponds to x of t, whereas output corresponds to 2 times x of t. So what is the input delay? Input delay means y of t minus t naught. So 2 times x of t minus t naught. Delay only the input. Output delay. Remember, while delaying your output, wherever you have t, replace it with t minus t naught. While delaying your output, wherever you have t, replace it with t minus t naught. But I am having t here only. These two are equal or not equal? Equal. So it is time invariant. Time invariant. TIV. TIV. Suppose if I take this one, second one, t times x of t. Here input corresponds to x of t, whereas output corresponds to tx of t. Input delay. Delay only the input. Output delay. Wherever you have t, replace it with t minus t naught. These two are equal or not equal? Not equal. So it is time variant. Time variant. Third one, y of t sine of x of t. Y of t is equal to sine of x of t. Come on, tell me, this is a time invariant or time variant? Time invariant or time variant? Sine of x of t. Input delay. Time invariant, x, exactly. Delay only the input. Output delay or output shift also you can say. Wherever you have t, replaced with t minus t naught. Both are equal. So it is time invariant. Y of t is equal to x of t cos t. X of t cos t. Y of t is equal to x of t cos t. Time invariant or time variant? Come on, tell me. Yt is equal to xt cos t. Yes, it is time variant. It is time variant. Input delay. Output delay. Not equal. Time variant. Okay. Number y of t x square of t. Y of t is equal to x square of t. Type your answer. Y of t is equal to x square of t. Time invariant. Input delay. time invariant. X of t square, y of t is equal to x of t square, y of t is equal to x of t square. Yes, Amitabh, you are right. Input delay or input shift, output delay, wherever you have to replace it with t minus t. Equal or not equal? Not equal. Time variant. Time variant. E power x of t. E power x of t. I think I need not solve this one. E power x of t. Time invariant. Time invariant. Suppose y of t is equal to x of 2t. Y of t is equal to x of 2t. Time invariant or time variant. Input delay. Look here. Input delay. Delay only the input. Output delay. Wherever you have to replace it with t minus t naught. So time invariant or time variant? Not equal. Time variant. Now what I'll try to do is I'll try to show this by taking an example. Using expressions anyway we are going to get no. By taking an example, we'll try to prove that y of t is equal to x of 2t is a time variant system, and after that we can arrive at a conclusion. Observe here all of you. The example I'm going to listen carefully all of you. So here I'm going to take a system. Look here. I'm going to take a system. Listen carefully all of you. With input x of t and output y of t. What is the input output relationship he gave? Y of t is equal to x of 2t. Y of t is equal to x of 2t. Now let's check by taking an example, because this kind of analysis is very much required. What happens? Look here. What happens if I apply an input like this? What happens if I apply an input like this to this system? Here if you observe, what is this operation? Scaling operation. And if you observe, the scaling factor is greater than 1. Means the output is nothing, the output signal what you are going to get will be a compressed version of the input signal. So if this is x of t, what is the output you can expect? 1 to 2. You can expect an output of 1 to 2. Right? Clear? Now observe here. How to check time invariance? Given input output relationship. What is the first step I said? Delay the input by t naught. Let t naught be 2. Look here. Let t naught be 2. What happens if I delay this input by 2 units? What happens if I delay this input by 2 units? It will go to 4 to 6. Yes or no? It will go to 4 to 6. Delay the input by t naught. Now you apply this signal to the system. What will happen? The nature of the system is it will try to scale the signal by 2 units. So what is the output you are going to get? What is the output you are going to get? So 4 to 6 means 2 to 3 will come. Divide each point on the horizontal axis with the scaling factor, no? Now observe here. What I said? Delay the input by T naught and denote the corresponding output as y of T comma T naught. Y of T comma T naught. And what the next step I said? Delay the output means this one. Delay the output by T naught. What happens if I delay the output by T naught? It will go to T naught value is 2, no, it will go to 3 to 4 and denote the corresponding value as y of T minus T naught I said. After that, I asked you to check whether y of T comma T naught is equal to y of T minus T naught or not. Here what happened in this case? Not equal. So it became time variant system. Hope this is clear. Please reply. I'm testing like this. Look here. Y of t is equal to x of 2t. I applied x of t. I got y of t. Now I want to check for time invariance. So delay the input by t naught and denote the corresponding output as y of t comma t naught. Delay the output. Delay the output by t naught and denote the corresponding value as y of t minus t naught. Now I'm checking whether input delay is this is input delay and this is output delay. They are equal or not? They are not equal. So time variant. Clear? Clear? Please reply, because I'm going to do a small modification in this example now. All of you must reply whether this example is clear or not. Right? Now what I am going to do is, look here, I am going to remove this 2. Observe here, my dear students. I am going to remove this 2. Means y of t is equal to x of t. Y of t is equal to x of t. Now what will happen if I apply this kind of input which varies from 2 to 4? What I'll get? Y of t is equal to x of t, no? So what I'll get here? 2 to 4 I'll get. Yes or no? Now delay the input by t naught. 4 to 6 will come. Now what happens if I apply 4 to 6? What happens if I apply 4 to 6? Again 4 to 6 will come. This is input delay. Now delay the output by t naught units. So what happens if I delay this output by t naught units? Again what I am going to get? 4 to 6 I am going to get. Here if you observe, input delay y of t comma 2 is equal to output delay y of t minus 2. In which case this becomes TIV. In which case it becomes TIV. Yes or no? Clear? All of you. TIV. Observe here. In the previous case, what happened? In the previous case, TV, time variant. In the present case, TIV. In the previous case, what is the scaling factor? 2. Now, what is the scaling factor? 1. In the previous case, scaling factor is 2. So, it became TV. Now, in the present case, the scaling factor is 1. So, it became TIV. Or, can I generalize like this? Look here. Time scaling operation, I can generalize like this. Time scaling operation is time variant. If scaling factor not equal to 1. Very, very important step. If the scaling factor not equal to 1, time scaling operation will become time variant. Understood? Time scaling is time variant if the scaling factor not equal to 1. So whenever you are given time scaling, observe the scaling factor. If it is not equal to 1 means you can simply put TV, time variant. Time variant. So in this way we went. This kind of analysis we have done. Hope this is clear for all of you. Time scaling operation is time variant if scaling factor not equal to 1. Yes or no? Reply. Jaitirda, Manu, Harish, Vamsi, Amitabh, Nandakumar. Clear? This statement is very, very important. Time scaling is time variant if the scaling factor not equal to 1. If you have any doubt, you can go with this kind of analysis. Right? If that is true, what is the number? I forgot the number. 5. Not 5. It is 9. No. Now, time scaling is time variant if the scaling factor not equal to 1. Suppose if I ask you this one, y of t is equal to x of t by 2 or t by 3 if I ask you. Y of t is equal to x of t by 3. Time variant or time invariant? Now observe, first of all, what is this operation? Time scaling. What is scaling factor? 1 by 3. Not equal to 1. So it must be time variant. Time variant. Suppose if I ask you this one, y of t is equal to x of minus t. X of minus t. X of minus t is what? Reversal. In the very first unit we studied, reversal is nothing but special case of scaling only. Scaling by minus 1 is reversal. So scaling factor not equal to 1. So it must be time variant. Time variant. Suppose if I ask you this one, yt is equal to OD of x of t, where OD stands for odd part. OD of x of t, where OD stands for odd part. How we are going to define the odd part? Signal minus its reversal by 2. Reversal came is time variant. Time variant. Vamsi Krishna, if scaling factor greater than 1 means we have done for this one only, right? I have done the example for x 2t, scaling factor is greater than 1 also, time variant. We have done the analysis for this problem for 8th one only. Vamsi Krishna, please verify. If the scaling factor is greater than, not equal to 1, it may be greater than 1 or less than 1, doesn't matter. Vamsi Krishna, please verify. Okay. In the same way, even part of x of t. Even part of x of t. Time variant, because reversal will come. Y of t is equal to d by dt of x of t. Y of t is equal to d by dt of x of t. TV or TIV? Input delay. Input delay. Delay only the input. Output delay. So this is operator, you cannot put t minus t naught here. Time invariant. Time invariant. So many of my friends will be having doubt how this differentiator became time invariant. If you have any doubt, our procedure is there, no? This procedure follow, observe here. Take a system, or I'll do in the other page, it's would be better. Look here. Differentiator, how it became time invariant. Test. Take a system with input x of t, output y of t. What is the input output relationship? Y of t is equal to d by dt of x of t. Fine. Now what happens if I apply inputs, apply some input, 2 to 4, same input as you are taking in the previous case I am applying. This is x of t. If you are going to do this kind of examples, what happens, you know, your previous basics will become strong. Now differentiate. What happens if I differentiate the signal? 2, 4. One impulse at 2, because discontinuity is there going in the upward direction, and impulse means area we want, final value minus initial value, this is 1. At 4 there is a sudden fall, discontinuity placed like this. So this is input, this is output. First step, delay the input by t naught units. Let t naught be is equal to 2. So what happens if I delay this input by 2 units? It will go to 4 to 6. 4 to 6. Now what happens if I apply this one to the system? I'll get one impulse at 4, one impulse at 6. Impulse at 4 will be like this and impulse at 6 will be like this. So y of t comma t naught. Now delay the output. Now delay the output means you delay this one by t naught units and denote the corresponding value as y of t minus 2. What happens? 4. If I delay by 2 units, 4, 6, it will come like this. Now you see whether these two are equal or not equal. They are equal, time invariant, otherwise time variant. Equal, time invariant. Yes or no? Yes or no? Yes. See, input I applied, output I got. Input delayed. So the output due to the delayed input I got the original output delay. Both are equal, so time invariant. Time invariant. Okay. Yes. Now, what is the number? 13, 14. Let's throw 14th one. Y of t is equal to integral minus infinite to t x of tau d tau. Minus infinite to t x of tau d tau. Input delay. Delay on integration. Input delay. Delay only the input. Delay only the input. Now let's simplify this integration. Let's simplify this integration by assuming tau minus t naught is equal to some k. What happens to d tau? Dk or input delay. Lower limit of tau is minus infinite, so lower limit of k is also minus infinite. Upper limit of tau is t, small t, so upper limit of k will be t minus t naught. X of tau minus t naught is k, d tau is dk. This is input delay. Output delay, wherever you have t, output delay, wherever you have t, replace it with t minus t naught, but I am having t here only. Call this as equation 1, equation 2. So if you observe, equation 1 input delay and equation 2 output delay, they are same, except here k is replaced with in the place of k we have tau. So whatever may be the variable, either tau or k, doesn't matter, both are same. So it is time invariant system. Time invariant system. Time invariant system. Okay. If you don't like this method, follow this one. You try to follow our integration, no? Do one thing. Apply a step input. Apply a step input. What will get? We'll get a ramp. Now you delay this step by 1 unit and apply. Definitely I'm not doing here, that is your work. So definitely your ramp will also gets delayed by 1 unit. So this is x of t. Directly I'm giving, you can verify after the class. So this is T naught is 1, I'm assuming. So this is y of t comma 1. Y of t minus 1 you try to do. Same thing you'll get. So input delay will be equal to output delay. So time invariant. Time invariant. This experiment I'm not explaining, just I have given the figures you have to do. You have to do. Right? Or take an input as impulse signal and integrate and observe what happens. So step signal must come. So delay the impulse signal, again apply. That kind of analysis you must do, right? If you're not satisfied with the procedure, means go with experiments. We have to do a lot of experiments. Number 10. Y of t is equal to integral minus infinite to 2t x of tau d tau. In the place of t, I substitute 2t. Time variant or time invariant, tell me. Do it. Minus infinite to 2t x of tau d tau. Do it and tell me. TV. Manu has said TV. TV. Okay, let's verify. Procedure we know, right? Input delay. Let tau minus t naught is equal to k. D tau is equal to dk. So lower limit of tau is minus infinite. So lower limit of k is also minus infinite. Upper limit of tau is how much? 2t. So this becomes 2 tau. Sorry, it is 2t. Upper limit of tau is 2t, no? So 2t minus t naught. X of k, d tau is dk. This is input delay. Output delay. While delaying your output, wherever you have t, replace it with t minus t naught. If you observe these two expressions, if I call this as first one, if I call this as second one, these two are not equal. Not equal. So TB or TIV? TB. Or if you don't like this procedure, go with this. Verify. These kind of experiments you must do at your home. Simply listening the class makes no sense. You have to do lot of experiments. You must fail. Then you'll you must clarify your doubts. Then you'll arrive at a conclusion. Mod of x of t. Mod of x of t. TV or TIV? TV or TIV? Mod of x of t. TV or TIV? The mod of x of t, TV or TIV? Yes, exactly. TIV, very simple. TIV. Right? Now, What happens if you are given a differential equation? Okay. How to check time invariance? How to check time invariance for a differential equation? Linearity we have seen. Then what about time invariance for a differential equation? Okay. The point you can write like this. Coefficients in the differential equation cannot be functions of independent or dependent variable. Independent or dependent variable. Look here, coefficients in the differential equation cannot be the functions of independent or dependent variable. Cannot be the functions of independent or dependent. For example, look here, dy of t by dt plus 4 y of t is equal to x of t. Second one, dy of t by dt plus 4t y of t is equal to x of t. Third one, dy of t by dt plus 4 y of 2t into y of t is equal to x of t. X of t. Fourth one, dy of t by dt minus 2y of t is equal to e power x of t. Now you classify these as time variant or time invariant. First one, observe the coefficients. See, time invariance means observe the coefficients. Here coefficients are not dependent on independent or dependent variable. So this is time invariant. First one is time invariant and it is linear also. Linear time invariant system. First one is linear as well as time invariant also. TIV, TV, TV, TV. Okay, let's verify. First one is what? Linear. Time invariant. How come time invariant? Observe the coefficients. Coefficients are not dependent on the independent variable or dependent variable. Okay. Second one. Here the coefficient is dependent on the independent variable. So linearity no problem. Linearity no problem, but time invariance not allowed. Linear time variant system. Linear time variant system. Okay. Now third one if you observe here 4 y of 2t multiplied with y of t. Here the coefficient is function of the dependent variable. So this is non-linear. First of all, non-linear, and the coefficient cannot be the function of dependent or independent variable for time invariance. Non-linear time variant. Non-linear time variant. Now coming to the fourth one. So here the coefficient is function of what? Dependent variable. So it is non-linear and is not allowed in time invariance also. Yes, Rahul, you are right. Clear? Let me check. JT the answer. Time invariant, time variant, time. JT the third one is wrong. Yes, yes. Okay. Clear? So this is about the time invariance. See, if you are given a differential equation, how to verify? Observe the coefficients. If the coefficients are dependent on the independent variable, if they are functions of independent variable or functions of dependent variable, simply time variant. If you observe, the coefficients are independent of, are all independent. They are not dependent on the independent variable or dependent variable. Second one, if you observe, the coefficient here is dependent on t. So time variant here, the coefficient is dependent on this one, y of 2t. Time variant here also. Yes, yes. Fine, fine. Now I'll do one thing. I'll give you a homework problem. Homework problem. If constant is present, no issues. Constant is allowed, Manu. Constant is allowed for time invariance, but is not allowed for linearity. Linearity is not allowed. Right? Manu, constant is allowed for time invariance, but constant is not allowed for time invariance. Sorry, constant is not allowed for linearity, but it is allowed for time invariance. Okay. Homework problem. I'm taking an LTI system. LTI system. So linearity we studied, time invariance also we studied. So LTI system is, it obeys both the properties, linearity as well as time invariance. Linearity means what? Total response is equal to sum of individual response. Time invariance means what? Shift in the input is equal to shift in the output. Right. To this LTI system, I'm going to give this kind of input. X of t, and I'm going to get this kind of output. This information is given to us. Given this kind of signal input, given this kind of signal x of t, we are going to get y of t. Now the question is, what happens if you are going to give this kind of x1t? What is your y1t? Means you have to draw the signal. X2t. What is your y2t? Okay. So given the information that x of t given to a LTI system produces y of t like this. Now I'm asking you, what happens if I give x1 of t? What is y1 of t? And what happens if I give x2 of t? What is your y2 of t? You have to draw the signals. You draw the output signals y1 of t and y2 of t. This is your homework problem, my dear students. Really, you can enjoy this problem. Use your linearity and time invariance concepts. Okay, so that's all for today's class. And tomorrow, what we are going to discuss? Coming up tomorrow, we are going to discuss the other property like causality, static and dynamic systems. If time permits, we'll go to stability and invertibility also. So that is the agenda for tomorrow's class. Don't miss the class. Okay. And finally, before leaving, you can follow me on Unacademy. Unacademy.com at KVSwami. And these are our channels. This is our Kreatryx channel, main channel. This is if you have any mechanical friends, you can refer this one. chemical and civil students, you can refer computer science gate questions. This is also computer science channel, Unacademy Gate English, electrical junction and apti express. And finally, thank you and save the date April 4th. April 4th is your Unacademy combat. Inform your friends also. Okay. And we are going to have after this unit is completed, again we are going to have a beautiful test on the second unit also. Don't worry. Okay. So happy learning.